Watch that video, it's no big deal, I'm showing it right now. If I collect these like terms, I get 6x squared, right? Minus x minus 2. Everybody cool with that to there? Expanding this out and getting that answer. Are we all good? Now we already know that if I factor this, I'm going to get this, right? We know that because this is factor, multiply them together, I get that. Everyone's cool with that, right? Let's pretend that none of this is there. All you have is this purple one, and I say factor it. Okay? Now, Mr. Duidoff has taught you one way to factor that. A lot of you said that was confusing and you didn't like it. That's fine. Maybe you will like my way better. All right? And we're going to start it right now. I'm going to move this over here, and we're going to start working from there. Now, tell me anything you can about that purple expression. Talk to me. Use some math words. What is it? It's a trinomial. Excellent. Good. What do we know? We already know how to deal with trinomials a little bit, yes? Because we have seen trinomials that look like this. That look like this. That look like this. That look like this. The trinomials we have seen have a similar structure to this, don't they? There's no coefficient, but otherwise they're exactly the same, yes? They have a squared term, which is called a quadratic term, but I will not ever make you know that. They have an x term, which is called a linear term, which I will not also make you know. And they have a constant, which is just a plain number. Everyone agrees? You all know what to do with... Well, nothing's working now. I took a long time to talk about that. You all know what to do with this. X squared plus bx plus c, right? You know you need numbers that multiply to c and add to b. You know how to do that, right? That's the regular factor we did forever. And nobody had any problems with it. Right? Or very few. Yeah? Okay. Well, now, this is slightly different. What is the coefficient right there that I didn't write? 1. Correct? 1. This number is 6. It is 6 times bigger than 1. Yes? So does it not make sense that if this trinomial begins 6 times bigger than this, and our first step up here is to multiply to c, shouldn't our first step here be to multiply to that first number 6 times c? Does everybody follow me? This is 6 times bigger, so instead of multiplying to that number, we're going to multiply to 6 times that number. Is everybody cool? So I need to multiply to negative 12. Agreed? Now, once we have made that change, we go back to our original plan. And our original plan says we need to multiply to something, which we know is negative 12 because we've done that little bit. But we add to b still. What is b in this trinomial? Negative 1. Right? Because we only care about the number, right? So we are going to add to negative 1. So what are those numbers? Is it 1 and 12? No, because 1 and 12 will get me 13 or 11, not negative 1. Is it 2 and 6? No, because that'll get me 4 or 8. Is it 3 and 4? Yeah. Yes. So we know this is going to be 3 and 4. Which one of those gets me to negative 1? Positive 3, negative 4. Everyone agree? Now watch. If there was no 6 there, the answer would be this. X plus 3 and x minus 4, wouldn't it? Everybody agrees there, right? If there was no 6, this is what we would write once we add these numbers, correct? Everybody agrees? Okay. How did we know that we had to go to 12? What did we do? Because we should have gone to 2, but we went to 12. Why? Because that coefficient made us have to multiply, correct? So if we multiplied way back at the beginning and we're trying to factor, doesn't it make sense that we do some division somewhere? Doesn't it? The only reason we knew about 3 and 4 was because we multiplied by 6, correct? So we'd better divide by 6 to find out what the real answers are. Now, would you ever leave that fraction? What would you turn that into? 1/2. Agreed? Would you ever leave that fraction? What would you turn it into? 2/3. Is everybody cool? So now I have x plus 1/2 and I have x minus 2/3. Right? Everyone agree? Okay. Look at that, because that's done now, isn't it? Right? We could FOIL that out and get an answer. It would be yucky because we would have a bunch of fractions in it, but we could do it, couldn't we? Look closely at all the letters and numbers in those factors. Everybody looking at them? Now look back here at what our letters and numbers are of our final factored answer. What do you see? That denominator moved there, and that denominator moved there, and it's done. It looks, I don't like to use the word, but it looks like it's some kind of cheap trick, right? That the stuff just moves and there it works. And I can FOIL this all out and prove it to you that it works. I can do that. Or you can notice and trust me. It's up to you. Now let's talk about the two different methods. We're going to do this question right here because Mr. Duidoff did it on the very back wall. Mr. Duidoff, I'm going to work in blue. Duidoff. And me, I'm going to show in purple because that's my favorite color. All right? If we were doing the Duidoff method, we would say to ourselves, self, 3 times 10, multiply to -30, add to -13. And we would know that it was 15 and 2, right? And we would rewrite it as 3x squared minus 15x plus 2x minus 10, right? Then we'd bracket the two binomials. We'd take out our common factor, 3x, take out our common factor, 2, and we get 3x, x minus 5, and out of here, plus 2, x minus 5, right? And then we would see, oh, x minus 5 and x minus 5, they're common, so they go to the front. And 3x plus 2, x plus 2 would be the other factor, right? That's Duidoff. And it works, it gets you the right answer. The problem is, look at how many steps, and it's a totally different thing than we've already done. Agreed? My method starts the same way. I still got to do that. I'm multiplying to negative 30 and adding to negative 13. But after that, it's what I already know, right? It's S. We know it's plus 2 minus 15, right? So S plus 2, S minus 15. But it's not 2 and 15 because I had to multiply by this 3. So once I get to here, I divide. And then I just simplify my fractions. Does that simplify? No. So the denominator goes to the front. 3s plus 2. I used x here, but it's s, right? Does that simplify? 5. 15 divided by 3 is 5. S minus 5. And you see you get the same answer. I don't care which one you use. I personally, when I was your age, was taught Mr. Duydov's method, and I found it to be cumbersome. I didn't dig it. But it was the only method anybody ever taught me. Then I got to teaching you people, not you people, but teenagers, and I showed them the way I was taught. And they were all like... So then, when the internet became a thing, I Googled how other methods to factor these. Because, of course, the internet has every piece of information ever in the history of human knowledge at your fingertips. Not just epic fails of 2018. And I used it to find information. And apparently some dudes in Australia figured out this move. And I liked it better. So I moved to that. But I don't care what you do. If you are from another country, and in here there are a couple, you have been taught a third method to do this that I really hate and refuse to teach you because it's all about guessing. And do I guess? No. I estimate before I do work. If I don't have to estimate, do I? No. And when you do my method, is there any estimation? No. You know it's plus 2 and minus 15. There's no guessing. Everybody good? Okay. Now, what would you like for me to do? Would you like for me to just show you the right answers? Then you can say, I need to see how to do number 5, for example. And then I would say, do you want to see Mr. Duydov's method or do you want to see my method? Or, I didn't finish yet. You don't have a both. Or, do I just very quickly go through all of these in one of the two methods? Here are the right answers, in case you care. They are highlighted. There is all of 137. You can check your work. There. Anybody want to talk about any of them? Everybody good? Awesome, possum. There is 5, 6, 7, 8. Anybody want to talk about any of them? Which one? 5? Okay. Now comes the question, do you want to see my method, Duydov's method, or do you care? No, I absolutely refuse. You can say it all you want. I'm going to continue to say no. The third, I don't even have a name for it. Some people call it box factoring. Some people call it, I don't know, because it's stupid. It requires you to guess. And you will end up drawing something that looks like this. You'll have a number there, a number there, a number there, a number there. You'll have a cross, you'll have a plus and a minus, and then you'll write your final answer as that number plus that number and that number minus that number. Yeah, exactly. Or you can do exactly what you already know how to do and have the right numbers the first try without ever guessing. I don't know why you would ever do something that would give you the possibility of a wrong answer when you have something that never gives you the wrong answer. Do you understand what I'm saying? That's why I will not show you the third method. So, when I look at this, I say to myself, self, I don't like 24. I want to see if I can get rid of it. I can't get rid of 24 because 20 doesn't work with it. But I can get rid of 4, can't I? So I'm going to get rid of that 4, and now I have 6h squared minus 5h minus 6. Yes? Everybody's good to there? It's GCF. It's the very, very first thing we did in factoring. Everybody should be able to do that in their sleep, right? Now you look at this and you say to yourself, self, that's a trinomial. I know 2 ways to factor trinomials. One, when there's nothing out in front. So let's see. Can I get rid of that 6? No, I cannot divide by 6 because 5 doesn't divide by 6, correct? So I got to use my other method. Now, Mr. Dewey-Doff taught me a method whereby I write 2 binomials and I factor them and then I factor that. Mr. Myers taught me a method where I only have to factor once. I don't care which. I personally know which one I like better, so I'm going to use that one. That was you thinking, right? I am going to use my method here. I say to myself, self, I know that if there was no h there, I would need factors of 6 that add to 5. Right? But there is a coefficient with that h. It's 6 times bigger than 1, so I got to bring that 6 to the end. So I need to multiply to negative 36 and add to negative 5. Negative 5 doesn't change. I'm going to leave that there. Is it 1 and 36? No. Is it 2 and 18? No. Is it 3 and 12? No. Is it 4 and 9? Yes. How will 4 and 9 get me to negative 5? Negative 9. And I know that if there was no 6 there, it would be h minus 9 and h plus 4. Correct? But the only reason I know it's 9 and 4 is because I multiplied by 6, right? So I got to get that 6 out of there. Divide by 6, divide by 6. Would you ever leave that fraction? What? Yes. Yes. Would you ever leave that fraction? What would you do with 9 and 6? I don't have anybody. You got to go. What would you do with 9 and 6? They both divide by 3. So I would get 3 over 2, correct? What would you do with 4 and 6? I get 2 over 3, right? Now, what do I do with the denominator? Moves to the front. What do I do with the denominator? We just did it. Moves to the front, 3h plus 2. And I had this 4 left over from the very beginning. And now it is done. Is everybody cool? Now, I want you to see something. You do not have to do this. I'm just going to show you something. H minus 3 halves. H minus 2 thirds. No, H plus 2 thirds. That was where we were before we moved the equations, right? Or before we moved the denominators, yes? Everyone agrees? Okay. Watch. What's h times h? H squared. What's h times 2 thirds? 2 thirds h. Agreed? What's negative 3 halves? That's minus 3 halves h, right? And negative 3 halves times positive 2 thirds equals negative 6 over 6, correct? 3 halves times 2/3. Everybody good to there? It's just FOIL, right? Everyone's okay, yeah? So I got h squared plus nothing. Now, 2/3 minus 3 halves is the same as 4/6, right? Minus 9/6, correct? 4 minus 9 is negative 5/6 h, right? Minus 6/6 is 1, correct? How would you get rid of that? You would multiply by 6, right? If I multiply this all by 6, what do I get? What does the h squared become? 6h squared. What happens to the 6's here? 6h squared. The 6's cancel. Minus 5h. And what's 6 times negative 1? Negative 6. What is that? Does everybody see? Why didn't I show you all the long way and prove it to you? Because as soon as I start adding and subtracting fractions, about 90% of you start to cry a little inside. Because you can't deal with fractions. That's not your fault. You were allowed to get here even though you never learned how to deal with fractions. And now it's biting you in the ass. I'm sorry for that, but I cannot fix 8 years of people letting you get by without knowing how to do stuff with fractions. That is why I don't have this in your notes. But now you should see what happens, why just moving those denominators works, because it gets us the same answer. Is everybody good? The only way to get good at factoring is like all other math. You've got to practice it. So I'm going to go back over to the right answers. There's the rest of 137. If you didn't write it down now, it's being recorded right now. They're all on YouTube. There's 138 up to 14. Remember here, you could write 3t squared plus 2 squared. I'd be perfectly happy with that. And then there is 15. Now, at 16, I want to stop for a second. I will scroll up in just 1 second. I've lost 16, but that's okay. $15 is a little tricky too. I wouldn't be surprised if somebody needed to ask me about 15. Does anybody? Nobody needs to ask me about 15? No one? Okay. What do I personally always do every time I have anything in brackets when I'm factoring? Hint, hint. I just did it on that. I change it to a single thing so I can deal with it more easily, yes? So if I write this as a squared minus 81, is it the same thing? Yeah. Because I've taken something, a, squared it, and subtracted 81. The way it's written now, I have something, x minus 7, squared, minus 81, right? So, if I rewrite this, and I'm just stalling for time till the stupid computer lets me write, as a squared minus 81. Is that a perfect square? And if the minus hadn't disappeared because it's a piece of garbage computer, there'd be a minus there, yes? And is that a perfect square? Yep. So I know if I was going to factor this, it would be the square root of the first one, which is what? What's the square root of a squared? A plus, what's the square root of the second one? 9. And then what would I write? A minus 9, because I already got the plus, right? Now, is there an a anywhere in the original equation?
No.
What is a? So isn't this really x minus 7 plus 9? What is negative 7 plus 9? X plus 2. And isn't this really x minus 7 minus 9? What's negative 7 minus 9? Negative 16. And it's done. Get it? Okay. Look over here. Is this squared minus squared? Yes. Can I write this as x and this is y? So isn't this x squared? I shouldn't use x because I've got x's in the original question, should I? What would be a better letter to use? Z looks like 2's. G, and do I need one letter or 2 letters? Why do I need 2 letters? Because they're different. So I could use G and F, couldn't I? So isn't this G squared minus F squared? So, squared minus squared. What's square root of G? G plus, what's square root of F? F. Then what do I write? G minus F.
Oh, wow.
Agreed? Can everybody get to that spot when the computer writes it up on the screen? Yeah. Everybody can? Okay. What's G? 2x plus 3. Plus, what's F? 4x minus 7. That's one half of this, isn't it? That's the yellow half. Yes. Where? Of course it is, because it's a difference of squares. G squared minus F squared, which is factored as square root of the first one plus square root of the second one times square root of the first one minus square root of the second one. So, everybody should be good with that and that being the same thing, yes? Okay, now I got to do the same thing over here where it's green. What is G? 2x plus 3. Minus now 4x minus 7. Correct? And that's the green half, right? In the yellow part, are there any like terms? Where? So I got 2x plus 4x, which is what? 6x. And I got 3 plus negative 7. What's that? Minus 4. Agreed? Are there any like terms in the green side? What? 2x minus 4. What's that? Negative 2x. Now I'm putting it over here on purpose. 3 minus 7. 10. I put it over here because we don't like a negative at the front, do we? Now, that is 90% done. If you got to there, I'd give you a B. I'd give you 75% on that question. Why? What do you notice about 6 and 4? They both will lose a 2, won't they? So this part, the yellow part, can be rewritten as 2, 3x minus 2, correct? What do you notice about the green part? I can take a 2 out and get 5 minus x, can't I? Now, does that break down any smaller? No. 2 is broken. The 2 and the 2 came out. That's as small as I can get it. Right? Do you understand why this is worth a little bit more in terms of marking from me? Because I want it factored completely, yes? And both these guys will send out a 2. Everybody cool? All right. There's 18. 2x plus 9, 2x plus 13. And I don't think I have the answer to 19 on here. Oh, I do. But you'll notice I stopped at the b, didn't I? Right? Because I could show you easily how to get to there, but you could go one more step from there. Most of you, in my experience, get to here and stop. That's why I've stopped here. That's a B. Why? What can come out of this side? 4. Leaving me with what? What would be the first term there? 4 has come out, and what's inside? X plus 2. What could come out of here? 2, and what would stay inside? 2x minus 3. And that's totally broken down. Does everybody understand? Now, some teachers will tell you they don't like the 2 and the 4 there, and they would say multiply that out. Some teachers will say they want to see this final answer as 8. X plus 2, 2x minus 3. Do you think I am one of those teachers? No. Would I also accept this? 2 squared x plus 2 times 2 times 1 second 2x minus 3. Would I accept that? Yeah. 2 squared is 4. 2. Would I also accept, now say it, Louis.
2 cubed.
2 cubed.
Would you also accept a computer
X plus 2, 2x minus 3. Would I accept any of this for the A? Yes. Does everybody get it? Now, I apologize I wasn't here. I apologize for the fact that you now have seen 2 different methods to do the same thing, one of which I deem to be harder. I am not trying to poison your minds against either kind of factoring. I don't really care.
You also missed Dad Joke Thursday, and I had good ones lined up.
Times are tough all over, buddy. There'll be future Thursdays. As a matter of fact, if I'm not mistaken, we still have about 12 Thursdays to go.
Mr. Myers.
I lie. 9 Thursdays to go. What? Yes, I will do so. But first, I'm going to explain what your next couple of days are going to be. Is everybody listening? You are going to spend the rest of today working on page 139. 139 has, listen to me, is all GCFing and the third kind of trinomial factoring. Because I personally think that that is the one that my students do the most poorly on. So your review for the factoring half of this unit is this page, page 139. But when you turn the page over, you will notice it is blank. Yes? On the blank page of 140, isn't it? On the blank page of 140, I'm going to put up another bunch of questions. Okay? They are all of the A-level type. All right? They're significantly harder. Do as much or as few as you wish. I have also, when I show you it, you will notice there are some of the difference of squares questions on there as well. Everybody with me? So do as much or as little of these. I'll fix it. I'll make it smaller so you can see it all. Son of a... Oh, they don't all quite fit at 100%. We'll go down to 90. They don't all quite fit at 90. We'll go down to 75. There they are. Okay? So, all of this stuff is the A-level factoring, right? So I'll call your attention especially to 6, 7, and 8, because 6, 7, and 8 are all difference of squares, even though they look uglier. Square root first, square root second. And then I threw in 2 expansion questions just to remind you how to do it. I expect page 139, and as much of these, of course, I'm going to show you all the answers tomorrow. As much of this as you see fit done for tomorrow. Okay? We will puddle around a bit with expansion factoring tomorrow. I'll give you a few more questions just out of my head. We'll practice it a bit more. And we are going to test on expansion, 9 and 10, and factoring on Wednesday. Then you're going to have 4 days where you don't have to think about math even once. Everybody understand? Except, of course, you think about math every day, whether you think you're thinking about math or not. All right? Yeah, go ahead.